All right, hello. It's day two, kind of. There were two day ones for you guys. So we're getting into the ACT science test. We're talking about data representation today. That'll be the bulk of our time together. Um, so let's get into it. Again, hopefully it's September 10th. Either you're in class here watching it with me, and I'll help you through it when you're in here in class with me, or you're at home in hopefully doing this on the right time. Remember that I'll be on that ACT third or fourth block Zoom meeting, depending, last 30 minutes of class. So quick reminder for you there. Third block, I would be getting on from 12:20 to 12:50. Fourth block, I'd be getting on 2:20 to 2:50. So look for the Zoom meeting then. I'll send out an email probably at that time to remind you. So what's the plan over the science test? There's a lot to read. You shouldn't. It will take you too long to read all that business. So we don't want to do that. Introduction to data representation. I'll talk about data rep, which are some of the easier passages you're going to have. You're going to have probably 6 passages on the ACT science test. Sometimes I do 7, but it's been 6 lately. And 2 of them are going to be data rep, and these are going to be the easiest passages. We'll talk about why most problems are going to tell you where to look. You're going to start there. Make sure you're looking for the right variables. We'll talk about strategies, how to perform well in these kind of problems. And the thing I'm just going to say over and over in this class, if you don't know where to look, you're going to end up word searching. There's going to be a funky word that tips you off as to where to look. It's only going to show up in 1 or 2 other places. Look there, and the answer is probably nearby. Keys. I got keys for everything. So we'll look at some keys. And then data representation homework number 1. That's going to be on you to do at home by yourself. I'll have a key posted for it. You should try it by yourself without looking at the key first. Ultimately, it's going to be about getting in the good habits. So I'm okay with you going a little bit slower through these problems right now if it means you seeing the patterns, developing the habits. That way you can go a little bit quicker later. Again, this is not probably 90 minutes of work. I don't think this is going to take you the full hour today. And hopefully this video is nowhere near 90 minutes. Hopefully this video should be close to 30, maybe less. So let me show you a few things. First off, I got a lot of keys for everything. So we're ready to go on that front. Don't doubt me there. Let's take first a look at the ACT science test. And I'm just going to flip through this relatively quickly. This is a form from April 2019. Maybe some of our seniors took this test. That would be possible, I think. That would have been end of their sophomore year, maybe. Anyway, it's, take a look at this. There are a lot of words, a whole lot of words, a lot of graphs, and hopefully you're saying, "Ooh, I like graphs," because those are generally gonna be easier. But we're looking at this test, and you're saying, "Man, there's a lot of words on the ACT science test." Yeah. The trick to it is, and the trick we'll hopefully notice today, is most of these questions are going to tell you where to look according to figure 3, based on figures 1 through 3. Do figures 1 and 3 based on figure 2. Even at the end of the test, there are going to be easy questions that you can answer. I pull up this test because this passage 6, at the end of this test, it's one of the easier passages there. You're going to see that this kind of passage is a data rep passage, one that you can answer by looking at graphs and putting your finger on stuff, which is easier than like having to think through things. You can point at the graph. So we're going to be looking at data reps today. That's going to be the focus for about the next week or so, focusing on these passages where I think you can do really well. Again, we're working through this right now. I'm going to mark it up on the document camera, but this is the passage I gave you on the last couple days in class. We're going to be working on this, so you're marking along with me. I'm going to pull up the document camera in a moment so you can see that. And then your homework will be it says group work number 1. You used to work in groups, now you're working solo. A couple passages on chemistry. Hey, you're going to find out that you don't know what they're talking about. But you can still get the questions right, even if you don't know what they're talking about, if you can read the graph. So there's going to be a lot of work on graph reading, and I've got keys, guys. Keys with me marking the text up. You're going to try this without looking at the key. You're going to give yourself a grade. And then you're going to go back and you're going to fix stuff. You're going to put your grade on there. You're going to scan all this in an Adobe Scan eventually, and I've reminded you the instructions there. But it's the marking it up. If you go back and mark it up, you're going to get most of the points. You get participation points for doing it. More than half of the points associated with the homework are going to be for the marking. So mark it up, and you're going to get an A in this class. You're fine. So those are the things we're going to work on today. I'm going to switch over to the document camera. All right. So if this is too grainy, I can try and annotate it in Zoom. I'm flexible there, but I am providing you the key so that you can hopefully be able to see. So I apologize if the resolution is a little crappy. It's the document camera. All right, so a reminder, it would be nice if you had some different colors here. I'm going to be marking with different colors as I work through problems. You should probably have some too. It's nice if they show up different colors when you scan them in. That way I can see that it's not just gobbledygook. So I'm just going to kind of rotate through pens as I work through. You should get out a highlighter or something to mark things up. I'm going to get out a highlighter and a pen, I think. So you should probably do the same. Oh, I got a big one. I offered you guys some, but nobody wanted one. So I'm going to grab a highlighter and a pen. We're going to mark this thing up. So data rep, what are these things? They're going to give you a nice opportunity to pick up time and points. What does that mean? They're easy. And they're fast. Unlike research summaries and conflicting viewpoints, those are the things we're going to talk about later on, they're almost entirely dependent on tables and graphs. That's nice. You don't have to read. No reading. No or little reading. Students can usually spot a data representation passage by noticing that the text does not have italicized headers. It does not. It's not going to be study 1, study 2, study 3. It's going to be, here's the data. There's a typo here. They're unconcerned with methods used to obtain the data, and that should be exciting to you. We don't care where the data came from. We just care about what the numbers are. So these are going to be generally easier to work. All right, I'm not too worried about that passage. The sequence in which data representation passages is relatively random. They could be stacked at the end of the test. You want to find these questions. You want to do these questions. It's important to stay disciplined with their pace. Remember, on this test, I don't know if I've even told you, you're going to have 6 passages, 35 minutes, 40 questions. And 2 of them are going to be data rep. These are the easy ones. We're going to do well on these because we're going to learn how to read graphs, and we're going to continue focusing on graphs for the rest of these 3 weeks. So you'll be good at these. These are the ones we need to flourish on. So we're going to look at a passage here talking about data rep. You could see me, I guess. Makes no mention of experimental methods. The text serves as a glorified key to the graphs. The text tells you what the graphs mean. All right. On data reps such as this, you can skip the text and go. I don't even want you to go straight to reading the graphs. I want you to go straight to answering the questions. We're going to see that they tell you where to look. You don't need to read really anything. You need to look at where it tells you to look and answer the question that it pokes you at. So let's open it up and let's work our first ACT passage together. When you're doing these, you're going to want to have both of them open to you at the same time. So you might tear that staple open. Now we'll take a look at this. How do I know that this is a data rep? Well, I know that this is a data rep because there is very little text here. I've got graphs. I've got 1 graph, I got 2 graphs. That's really all I've got. I've got very little text. Let's take a look at something real quick. Let's turn to the questions. Let's take a look at every single question except the last one. And I've got 6 different colors because I got 6 different questions. I'm going to mark through these for you real quick. Look at number 15. It tells you where to look. Look at number 16. It tells you where to look. Hot dang. Look at number 17. It tells you where to look. 18, hooray. Tells you where to look. And 19, hot dang, tells you where to look. You'll notice that every question except the last one tells you exactly where you need to be looking. You don't need to read stuff beforehand if it tells you where to go to find the answers. So let's set to work. So you're going to notice I'm putting boxes around where the answer is. So figures are going to get boxes here. What else am I going to do? I'm going to tend to circle math stuff that could also be numbers, and I'm going to underline the names of variables and words that I think are important. Vocabulary. So I'm going to box in where I'm looking. I'm going to circle numbers, mathy sorts of things, higher, lower, that sort of business, and then I'm going to underline variables and words that seem to be of importance. I'm going to keep basically doing that for the next 3 weeks, so, let's go. Number 15, according to figure 2. Okay, great. The solar radiation intensity. Do I know what that is? No, but I'm going to underline the word solar radiation intensity because that seems like the variable. And then I'm going to see 8,000 years ago. What am I going to do? I'm going to go to figure 2. Hot diggity dog. I'm going to look at solar radiation intensity. It's right here. Look at that. It's on the left axis. Look at the other side. Concentration of CH4. They're trying to trick you. They're going to do this thing. They put graphs with multiple axes. They are trying to trick you. Make sure you underline the right variable. It's key to look at, that's a way they get wrong answers out of you. You look at the wrong side of the graph. So solar radiation intensity, I have 5,000, I have 10,000. Okay, so this must be 6, 7, 8, 9. 8,000 years ago, I'll draw a little line up to the graph, noticing that solar radiation is the dotted one in the key up there. And then I'll go ahead and take it over to the y-axis, and I see I've got an answer of 500, and I just followed some arrows around there in my mind. That's an easy one. There you go. First one we've done. Congratulations. C. So that's what I'm expecting of you in terms of work. You're going to be marking every single one of these problems up in these videos with me, just like I do. That's the expectation. I got a key that tells you what you can do. I'm sorry if the colors don't exactly match up from the video to the key. I made the key last year. Going to figure 2. If the, okay, that's a word. Trend in the CH4 concentration had continued to match, okay, the trend in solar radiation intensity. The CH4, oh man, that's a lot of words. Okay, if it had continued to match, if CH4 had continued to match solar radiation intensity, what would CH4 at present be? Well, at present, that's kind of a number. It's a tricky number. That's 0 years ago. Let's go back up to figure 2, and we see here present. Okay, so we're going to be looking for something there. We want to know what the CH4 would have been if it had continued to match. Well, think about that. So here's CH4. That's CH4, that squiggly one. Well, it stopped matching. What would it look like if it had continued to match? That's the if. If you see that word if, that's talking about a hypothetical situation. What if this had happened? You're going to have to make some conclusions from the graph. Maybe say, okay, well, what if it had continued to do this? Okay. So that's 15 and 6. Oh, 2 down. Hot dang. Number 17. Suppose. That's going to be one of those words we always need to circle in here. It's a tricky word. I'm gonna circle it. Suppose. When I see suppose, that's another hypothetical. Suppose that whenever CH4 concentrations increases, that's a math word. we have an immediate increase in temperature. And whenever CH4 decreases, we have a corresponding decrease in temperature. So what is that? When CH4 goes up, temp goes up. And when CH4 goes down, temp goes down. That's what that's telling you. Based on figure 2, which represents a plot of temperature? Well, temperature is going to look like CH4. What does this tell you? When CH4 goes up, temp goes up. So if we have right here CH4, that's what CH4 did. CH4 went down and then went up. What's temperature going to do? That is a shape matching question, boys and girls, children of all ages. That is a shape matching question. Can you match the shapes? Seriously, you can do this. Number 18, keep on working. Based on figure 1, the average, ooh, that's a mathy word, solar radiation intensity, that seems like a variable. Over the past 25,000 years, we got closest to, okay. So we're got to go back to figure 1. We haven't looked at that one before. Told me solar radiation intensity, so that's the dashed one. Solar radiation intensity is over here. And it asked me about the average. Well, where the heck's the average? It's not, I can't add these up. You don't get a calculator on this. How do you find the average? Average is going to be in the middle. Where's the middle? I don't know, right about there. Looks like about 480 to me. Nothing more complicated than find the middle of the graph. Average, remember, is kind of the, ooh, did I break my pen? The middle number. So, cool. H, 480. I might have broke my pen. All right, 2 left. Then you guys get to try one on your own. I'm going to do it for you, but you're going to pause and you're going to try it on your own in a minute. Ooh, new thing. A word in italics, solar radiation cycle. If you got a word in italics, that tells you it's a new word. Probably one worth paying attention to. Is the time between a maximum and in solar radiation intensity and the next maximum. So what does that look like? We're talking about this. We're talking about the period of the function. If you're coming from a little trigonometry, we're talking about peak to peak. How far are the mountains apart? Like maximum, the top. Do you know what maximum is? If you didn't know what maximum is, that was a hard question. The biggest. So we're going to go back to figure 1. Again, most of these questions are telling us where to look. Solar radiation intensity, again, that's the dashed one. And how far apart are these peaks becomes my question. And they say each one of them is, I don't know, about 2 tick marks apart. How much is a tick mark? A tick mark looks to be about 10,000 years. 10, 20, 30, 40, 50 thousands of years ago. So it looks to be about 2 times 10 is 20,000 ish. What does the graph say? What do the answers say? I got one between. Notice it was a between question. You didn't have to get it exactly right. You just had to get close. And then the last one, which I know is tricky, or could be, because it doesn't tell you where to look. Which of the following statements best describes the primary effect of CH4? I see that primary effect of CH4, and I think that that's time to word search. Let's go look for CH4. I think that pen's died. If you go look back in the text for effect of CH4, methane, warm Earth's climate. You can do that. So it's going to warm. So what do we get? Absorbs heat. Okay, what do we got? We got cooling, we got warming, we got cooling, we got warming. Notice you can get rid of some of those right away. So they're not cooling anything. Get rid of H and F. They warm. It told us that. In order to warm, do we need to absorb heat or give off radiation? Makes a little more sense that we might be absorbing heat. Answer there's J. So hopefully we can do that. All you need to do there was really follow along. I don't expect you. I expect you could have got most of those questions right yourself. The harder questions, notice, were at the end. Let's do one more in the video together, and then I'll send you on your way to do the homework. So on the next page, oh yeah, that pink really bled through on me. We've got a very exciting one about some block masses. Why don't you pause the video, get your phone out, go to like Google and type in 6-minute timer. I don't care if you get them all right. I just want you to know how much time you're actually going to have on a question like this. And it's about 6 minutes to do these 6 questions, about, a little less than a minute a question. Pause this video, stop, try it yourself with a 6-minute timer on, then come back and watch this and see if you did it right. There's the bell. So hopefully you've paused it, and hopefully you're back with me. Let's work through this. If a block, great, was pulled toward the east, the frictional force exerted by the block on the surface was directed. It doesn't, you just kind of gotta know about friction. If I drag something one way, which way does friction act? Friction always gonna act in the opposite direction. This is one of those where you just gotta know how friction works. Drag a chair across the room. It's not helping you go with it. The chair is not chair's not saying, "Ooh, yeah, you got to come with you." The chair's saying, "Nope, I'm trying to go the other way." So what is the opposite of the east? That would be west. That's kind of a weird question to start here. This is kind of a weird data wrap, I'll be honest with you. Number 22, based on figure 2. What is the order? I'm going to circle that word order. It's kind of a mathy word. What is the order of the 3 blocks from shortest to longest time to reach 15 meters per second? Shortest to longest. So I'm going to go down here and look at figure 2. I'm going to look at a speed 15 meters per second, and I'm just going to draw a line out there. Who was first there? 2 was first. 2.5 was second. 3 was third. 2, 2.5, 3. It's a quick one, hopefully. Let's answer F. Based on 23, I don't like this question too much either, so I'm not mad if you missed it. What was the approximate value of the acceleration? You might not know what acceleration is. And if you don't know, acceleration is change in, we'll say, speed over change in time. If you're in physics, you know that's kind of wrong, but for us right now, it's fine. What is acceleration? How much speed we changed, how much time we changed. That's rise over run, folks. That's the slope of the line. You look over here at figure 2, you look at this 3-kilogram block. What was the rise? The rise was 15. The run was 3. We're talking about 15 over 3 is 5. If you didn't know what acceleration was, it was hard to answer that question. There's going to be a couple questions in each test that require you to know a little vocab. Maybe 4 questions on the test that you have to know some vocab, and that happened to be one of them. Number 24, based on figure 1, and the results of experiment 1 are best modeled by which of the following equations? Oh, these look like y equals mx. Good deal. Notice figure 1, pulling forces on the y-axis, block mass is on the x-axis. What's my slope of this line? Up 5 over 1. Slope is rise over run. equals 5 over 1. So it looks like my slope is 5. Pulling force is on the y-axis. Block mass is on the x-axis. Looks like my answer is J. If you didn't remember, that's slope-intercept form. Y equals mx plus b, where m is the slope and b is the intercept. We'll talk more about that when we get to algebra. But here's your slope and your intercept down here at 0. Okay. So 2 questions left, and then you're off to the races. At each of the times plotted in figure 2, except 0. As block mass increased, what did the block speed do? Let's look at figure 2. Down here. At each of the times, as block mass increased, what did the speed do? Well, here at time 1, went down, went down, went down. As the mass goes up, the speed goes down. As mass goes up, speed goes down. So it decreased only. And the last one here with the pink, suspect pink marker, based on figure 1. An applied force of 30 newtons would that's a dangerous word, most likely have been required to maintain the constant speed of a block having mass of what? You're going to find that there's no question marks at the end of these things. It's like the mass is what? It's never going to pose with a question mark. So you got to know that that thing they mentioned at the end, that's what you're trying to figure out, the mass. But what's the issue here? You look over at figure 1 and you say 30 isn't there. We'd have to kind of stretch that line up. So how would we get up there to 30? I don't know. Looks like maybe that. What's out there? I don't know. Maybe this is like, stretch that line out. Looks like it's something out there. What's all the way out there? I don't know. Looks like it's bigger than 5. Maybe it's 6. That answer might not be satisfying for you. The answer of 6 from that might not be satisfying. You might not like that. It is the answer. What's another way you could have found it? You had that equation earlier. What was that equation we got earlier? Force equals 5 times mass. If you put in there for force equals 30, 5 times mass, if you went back and solved for mass there, you'd find that your mass equals 6. So you can use the equation to do it that you established, if you establish the equation right, or you can kind of just like stretch the graph out. What's that called? That's our very first example of something called extrapolating. Looking outside the data range we got, extra, it's outside, looking outside the data range we got to make predictions. So that's what I've got for you. You now can work through group work number 1. Should be working through this guy. It's homework. If you're here in person, I'm okay with you guys discussing it reasonably. If you're at home, you're probably working it solo. Again, make sure you're marking it up. There's keys available online on Schoology. Make sure you're checking those out before you post. The thing that I need to see uploaded for the practice, it's all just did you mark it and did you grade it. For the homework, the group work, it's mostly did you mark it with a little bit of did you get it right. Don't lie to me too much. All right, good luck, Godspeed. If you're having trouble uploading stuff, we can upload, and I don't have you today, we can upload tomorrow and it'll be fine.